Welcome to NJP Online Mathematics. Let's solve this lovely mathematics problem that we have here together. We are to determine the value of x to satisfy this equation here. So the equation is x to the power of x squared minus x cubed equals the root of 2x minus 1. So we have to determine the value of x. So let's give the solution to this problem. So we have x to the power of x squared minus x cubed equals the root of 2x minus 1. So for us to solve this problem, we have to take the square of both sides. If we take the square of both sides, then we're having the whole of this all squared and this square. So this square here takes away the root. Therefore, we are having this equals this. So we have to recall from the law of indices where we have a to the power of m, and it's written in this form that this is the same thing as a to the power of mn. That is to say the n here multiplies the m, which is the exponent of a. So it can also be written as a in this form, and this can be written as well as a to the power of mn. Therefore, these two here multiplies the whole exponent of x, which is x squared minus x cubed. Therefore, we can continue solving by saying that x to the power of 2 multiplying x squared minus x cubed equals 2x minus 1. Recall that the square have already taken away the root. Therefore, we are having 2x minus 1. So we have to continue to solve for the value of x. So we have to multiply through by 2 at the exponent of x. So if we do so, we are having x to the power of 2x squared minus 2x cubed, and this equals 2x minus 1. We want the exponent of x here to be the same thing as 2x minus 1, which is the right hand side of this equation. So for us to do that, we have to simplify the exponent of x here. So simplifying the exponent of x there, we are now going to simplify it to be x to the power of x squared plus x squared. Recall that x squared plus x squared equals 2x squared. So we have just splitted this and we write down the remaining thing, which is 2 minus 2x cubed, and this equals 2x minus 1. So this is what we are having. So since we are having this, let's continue solving. So we now have this, and this can also be rearranged. The exponent of x on the left hand side here can also be rearranged to be x to the power of x squared, this x squared here, minus 2x cubed, taking the minus 2x cubed forward and bringing the x squared backward, plus x squared, and this equals 2x minus 1. So this is what we have gotten. So now we have to apply the law of indices. If we have a to the power of m plus n, which is the addition law of indices, that this is the same thing as a to the power of m multiplying a to the power of n. As well, if we have a to the power of m minus n, then we are having a to the power of n multiplying a to the power of minus n. So since we are having this and it can be written in this form, we can apply this law here. That is to say, we are having x to the power of x squared multiplying x to the power of minus 2x cubed plus x squared, and this equals 2x minus 1. So recall we said the exponent of x here, which is the whole of this, must be the same thing as 2x minus 1. That means we must have this in the exponent here. So for us to do that, we are going to factor out minus x squared. So we are now having x to the power of x squared all multiplied by x to the power of minus x squared. And if we factor out minus x squared in this expression, this here, we are now going to have 2x minus 1, because minus x squared multiplied by 2x equals minus 2x cubed, and minus x squared multiplied by minus 1, this becomes minus minus, which is equal to plus, and x squared multiplied by 1 is x squared. That is how we obtain this, and we are now having that this equals 2x minus 1. So since we are having that the exponent of x here is similar to this, so we have to divide through by the whole of this expression. And if we divide through both sides by this whole expression, we are having this divided by x to the power of minus x squared multiplied by 2x minus 1. And we also divide it through by the right hand side, and we are having x to the power of minus x squared multiplied by 2x minus 1 here, as we are having it. So this cancels out, and now we are now left with x to the power of x squared, this alone, when these have cancelled out, and this equals 2x minus 1. Recall that here we are having 1 divided by x to the power of minus x squared multiplied by 2x minus 1. This is what we are having here. But we have to recall from the law of negative index in indices that if we have 1 divided by a, that this becomes a to the power of minus 1. It is referred to as the law of negative index or the reciprocal law. So if we have this, it can be expressed as a to the power of minus 1. So this here can be expressed as this to the power of minus 1. So if we continue by doing that, here we are having on the left hand side that x to the power of x squared equals 2x minus 1 multiplying x to the power of the whole of this to the power of minus 1. The minus times this is positive, so we are having x squared multiplying 2x minus 1. We have just applied the law of negative index. So we have to continue. Recall that this is the same thing as this, but we want the whole exponent of x to be the same thing multiplying the whole of this here. Therefore, we have to multiply through by x squared. So if we multiply both sides by x squared, the left hand side we are now having x squared multiplied by x to the power of x squared, and it equals x squared on the right hand side multiplied by 2x minus 1 multiplied by x to the power of x squared multiplying 2x minus 1. Now we have gotten that the whole of this here is the same thing as the exponent of x, which is x squared to the power of 2x squared multiplying 2x minus 1. So since this is the same thing as this, we need to recall that if we have x, that x is the same thing as e to the power of ln of x. This is the same thing as this. So since this is the same thing as this, if we are also given x squared, that is the same thing as e to the power of 2 ln x. So since this is the same thing as this, we have to apply this law here. So let's substitute. Let's do it here. We are now having x squared. So multiplied by recall that the exponent here becomes the number multiplying the ln of the base. So this is the exponent, and it will now multiply the ln of the base, which is x. We are done with this. So we have to also simplify the right hand side of the problem. So the right hand side, we are now having x squared multiplying 2x minus 1 multiplied by e. Recall, we are applying this rule here. E. So the exponent multiplying the ln of the base. So the exponent of this here, the exponent of x here is x squared multiplied by 2x minus 1. So we write it x squared multiplying 2x minus 1, and it then multiply the ln of the base. The ln of the base is x. So we have finally gotten this problem. We see here that we are having x squared multiplied by e to the power of x squared ln x. And here we are having x squared multiplied by 2x minus 1 multiplied by e to the power of x squared multiplying 2x minus 1 ln of x. So for this to be the same thing as this, so that we can apply the product law of Lambert W function, we have to multiply both sides by ln x. So if we multiply both sides by ln x, then we are having x squared ln x multiplied by x squared multiplied by ln x multiplied by e to the power of x squared ln x equals x squared multiplied by 2x minus 1 multiplied by e to the power of x squared multiplied by 2x minus 1 ln x. So recall, we are multiplying this by ln x as well. So we are now having this. So from here, that we are now having that x squared multiplied by ln x multiplied by e to the power of x squared ln x is equal to x squared multiplying 2x minus 1 ln x multiplied by e to the power of x squared multiplied by 2x minus 1 ln x. So we see that the power of e here is the same thing as the whole of this, and the power of e here is the same thing as the whole of this. So we have to take the Lambert W function of both sides. If we take the Lambert W function of both sides of this problem, then applying the law, we have to recall that the Lambert W function of any expression in the form of a multiplying e to the power of a equals a. Therefore, we have gotten a problem that this is the same thing as the exponent of e, and this is the same thing as the exponent of e. And whenever we are looking for the Lambert W function of any expression such that the number a is multiplied by e to the power of that same number, it automatically becomes the number itself. So if we apply that here, finding the Lambert W function of both sides, we are having x squared ln x multiplied by e to the power of x squared ln x squared ln x for the left hand side, and on the right hand side we are having the Lambert W function of x squared multiplied by 2x minus 1 ln x multiplied by e to the power of x squared multiplied by 2x minus 1 ln x. Since we are now having this, we need to apply that product law, and the product law here applies. So this, the Lambert W function of every expression in the form of this equals a, and this is in that form where this is the a. So here we are having x squared ln x, and the whole of this becomes x squared multiplying 2x minus 1 ln x. So we can see the equation that we have now obtained at this point in time. So since we have obtained this equation, now, we have to divide through by x squared ln x, because x squared ln x is common to both sides of this equation. So if we divide through by x squared ln x, divide through by x squared ln x, that is x squared multiplied by ln x, and this will cancel out, and this as well will cancel out. So here, this divided by this is 1, and 1 equals, what is left on the right hand side is 2x minus 1. So since this is equal to this, we have to make 2x the subject formula, and by transposing, and we'll take this to the left hand side, that is 1. Since this is minus, when it crosses over the equal to sign, it becomes positive 1 equals 2x, and therefore let's turn this equation upside down. Then we are having 2x equals 1 plus 1, which is 2. So we have to divide through by the coefficient of x, and the coefficient of x is the number multiplying the unknown x, which is 2. So if we divide through by 2, then we are having that x equals 1. Therefore, the final solution of the problem, which was given to us initially, and the equation that was given to us to find the value of x to satisfy the problem there, was this that we have here, that x to the power of x squared minus x to the power 3 equals the root of 2x minus 1 to determine the value of x. And we have just determined the value of x in this equation here by applying the Lambert W function. And as we applied this law, we were able to determine the value of x, which will satisfy this equation. So let's check if x equals 1 will really satisfy the equation that was given to us. So we have to check through for the value of x. Yeah, so let's check if x is really equal to 1. So if x is equal to 1, then the left hand side will be equal to the right hand side. So let's start with the left hand side. The left hand side, we are having x to the power of x squared minus x cubed. Let's substitute the value of x there, which we have just determined, and the value of x is 1. So we are having 1 to the power of 1 squared, which is 1, minus 1 cubed, which is 1 to the power of 3, which is 1 times 1 times 1, which is 1. So we are having 1 to the power of 1 minus 1, and 1 minus 1 is 0. So 1 to the power of 0, recalling the law of zero index, and the law of zero index says any number to the power of 0 equals 1. That is to say that the left hand side of this equation equals 1. So let's consider the right hand side of this equation. The right hand side of this equation here, that we are given the root of 2x minus 1. Let's just go above, substituting the value of x there, which is 2 times x, which is 2 times 1, which is 2, minus 1, and 2 minus 1 here is 1. So the root of 1, we know that the root of 1 is automatically 1, since 1 square equals 1. Therefore, we see that the right hand side is truly equal to the left hand side. So since the left hand side is equal to the right hand side after substituting the value of x there, then the value of x is already true for this equation that we have here. Therefore, we have now confirmed that the value of x to satisfy the problem we were given is truly 1 after applying the Lambert W function of both sides. Thank you for watching. Kindly like and subscribe.